Welcome back. In the second part of this lecture, we'll be talking a little bit more about equations of straight lines. Just doing another example here of graphing. In the previous video, we graphed a straight line by using its slope and then using that to generate a couple of extra points. If you've already got your equation written in general form, then it's really fast for you to find your x and your y intercepts. And so that might be the better approach if you're thinking of graphing a straight line. First, start out by finding its x and y intercept, and then plot those 2 points, connect them, and there you go. So that's what I'm going to do here. I've got an equation 3x plus 5y equals 20, and I'm going to start by finding the x-intercepts and the y-intercepts, and then I'll graph them, and then I'll get my graph of my line from that. So for my x-intercept, I'm going to be letting the y value be 0. And so that means I would have 3x plus 5 times 0 equals to 20, or 3x equals 20, or x is 20/3. So I have my x-intercept, 20/3, comma 0. So this number, 20/3, that's the same thing as 6 2/3, so it's just a little bit shy of 7. You might be tempted to turn this into a decimal and say that it's 6.6, but of course it's not 6.6. If you turn 20/3 into a decimal, it would be 6.6666666 with infinitely many sixes, and there's no way to write that without doing any sort of rounding off. So I will say that we're not going to write this as a decimal number and round it off to 6.6 or 6.67. We're going to keep it in this exact form, this fraction form of 20/3. I'll find my y-intercept much in the same way. I'll start by letting the x value be 0. So 3 times 0 plus 5y equals 20. Or 5y equals 20, which tells me that y is 4. So we have the point 0, 4. Okay, so we're pretty much ready to go because we have our x-intercept, we have our y-intercept, and now we're going to draw both of those or plot both of those, connect them, and that will be the equation of our straight line. So let's start with plotting these 2 points. And you'll see that I've got my x and my y-axis already laid out for me. And so all I need to do is plot my 2 points. The one point I had was 0, 4. That was my y-intercept. That one I don't have to label because, again, that's on a tick mark. But something like 20/3, which is close to 7 but not quite, that I will need to label. So that point, I'll label that as 20/3, comma 0. That way, whoever's looking at this will know the exact point at which crosses the x-axis. They won't have to guess. And that's the whole idea here. We don't want to make people guess at what our answer is. So I've drawn my line. I'll just put arrowheads on it. There we go. So I have my line is drawn. I have my 2 points that I've plotted. They're both there. The one that needed to be labeled has been labeled. The one last thing that I really should do is label the equation of my graph itself. 3x plus 5y equals 20. And then there we go. Just always doing a little double check before we stop with any graph. Make sure that your x and y axes are labeled, that it has tick marks on it that are labeled, that any points that you plotted are labeled, with the exception of ones that are on a tick mark, that the equation that you graphed is labeled. So here, everything is labeled as it needs to be, so we can move on to the next. So at the very beginning of the previous video, I said we were talking about equations of non-vertical straight lines, and that we could use the slope-point form or the slope-intercept form or general form to write them, and that for any non-vertical line we would have a slope that we could calculate. Here we're going to talk about vertical lines and horizontal lines briefly. So first, starting with the easier one, which is the horizontal lines. If you're a horizontal line, then that would mean that all the points on you would happen to all have the same y value. So if you're thinking about what the slope is, slope being the change in the y values over the change in the x values, no matter which points you happen to pick on that horizontal line, there'll be a difference in the x values, but the y values will always have a difference of 0 because they're always the same y value. So for a horizontal line, your slope should be 0. That means that if you're thinking about that slope-intercept form for the line, that since the slope would be 0, then the equation for your horizontal line should just be y equals whatever the y coordinate is where you pass through the y-axis. In other words, if you're thinking about a horizontal line that passes through the y-axis at the point 0b, that would be a line whose equation would be y equals b. And of course, any other point on that line would also have that same y value of b. So not a surprise that the equation is just that y equals b. Equivalently, if you're thinking about a vertical line, although the slope for a vertical line is undefined, if your vertical line goes through the point A0, then any other point on that vertical line would have that same x coordinate of A. So you could describe this line just by saying that x is equal to A, that on this line, the x coordinates are always A. So as this example goes, we've got a point 3, 4, and we want the vertical line that passes through that point and the horizontal line that passes through that point. So for the horizontal line, that would just be y equals whatever the y coordinate is, which is 4 in this case. And for the vertical line, that would be x equals whatever the x coordinate is, which is 3. One little property that we have here is the relationship between the slopes for parallel lines and the relationship of the slopes for perpendicular lines. Perpendicular lines, those are lines that meet at a nice 90-degree angle. So if we're thinking about parallel lines are both trending in the same sort of way. Not a big surprise there that parallel lines should have the same slope. Notice how I've written this. I say that the lines are parallel if and only if m1 is equal to m2. And so by that I mean if you know that the lines are parallel, then you can conclude that their slopes are equal. But the reverse is also true. If I give you two equations and you find out that they both have the same slope, then you can conclude that those equations are of lines that are parallel. For perpendicular lines, we have, and it can be phrased in a couple of different ways, the relationship between the slopes. One way to phrase them is that for perpendicular lines, the slopes must multiply together to give you -1. The other way of phrasing it would be that one slope would be -1 divided by the other, which is another way of thinking about the relationship between the slopes, that whatever the slope for the first line is, the slope for the second line would have to have the opposite sign and be the reciprocal. So, for example, if you had a slope that was -3/4, then that would mean the perpendicular slope would be positive 4/3, changing the slope and taking the reciprocal. So let's do that here. We want to find the general form of the equation of a line that passes through this point, 3, 1, and it has to be perpendicular to this line that we've been given. So my plan here is, if it's going to be perpendicular to the line that I've been given, then I need to know what's the slope of that line. So I'll start with 4x minus 3y equals 5, and I'm going to start by finding its slope. And of course, the easiest way to do that is to use slope-intercept form, to rewrite it with y on one side and everybody else on the other. So for the line that we've been given, we can find that the slope is positive 4/3. So that means that if we're thinking about a perpendicular slope, that should be the opposite sign, so negative, and the reciprocal, negative 3/4. Okay, so we know then the line that we're interested in is supposed to have a slope of negative 3/4 because that would be the perpendicular slope. And we also know what point it passes through, so we can create our equation of our line. The line is supposed to go through 3, 1 with a slope of negative 3/4. So I can use my slope point form. Y minus the y-coordinate equals my slope times x minus the x-coordinate. And I'm going to do the same thing that I did before, which is I'm going to clear out my fractions by multiplying everybody left side and right side by 4. So that on the left side I'd have 4 times y minus 1, or 4y minus 4. And on the right side I'd have negative 3 times x minus 3, or negative 3x plus 9. And we're interested in leaving this in general form, which is x's and y's on one side and everybody else on the other. And so there we go. I have my equation of my line 3x plus 4y equals 13. That should go through the point 3, 1, and it should be perpendicular to the line that we were given. All right, one last example here. I have a line that we're given, and we want to create the equation of a line that's parallel to it and passes through the y-axis when y is equal to 3. Okay, so first, before we do anything else, we know that the line that we're going to create has to be parallel to this one, to 4x plus 2y equals 7. So my first job is, what is the slope of that line? And I'm going to do the same thing that I did with the last example, which is rewrite this in slope-intercept form, bringing the x to the other side and solving for y. And so we can find that the slope is negative 2. That means that a parallel line would also have the same slope. So the line that we're going to create should also have a slope of negative 2. Now, we're interested in giving our answer in slope-intercept form, which works out kind of conveniently for us here because we're told that the line that we want to create passes through the y-axis when y is equal to 3. And of course, if you're thinking about what does it mean to pass through the y-axis, that's referring to a y-intercept. So really what we're being told here is that the y-intercept is 0, 3. So the y-intercept for our line is 0, 3, which means that if we're thinking about using slope-intercept form, y equals mx plus b, we know everything that we need. We know what m is, that was our slope of negative 2, and b, that would be the y-coordinate for the y-intercept. Since the y-intercept is 0, 3, then b is equal to 3. And so there we go. This would be the equation of a line that's parallel to the one that we were given and also should pass through the y-axis when y equals 3.